Welcome back, chat. Today's lesson's going to slap. No cap, my guys. Awful. Love it. Okay, we are looking at the complex numbers, and specifically the imaginary numbers. Now, the last thing that I remember talking about, and we didn't write a ton of it down, but we talked about clocks for a few minutes. Do you all remember talking about clocks? It was like this. If it's 10 a.m. and we add 7 hours. Yep, so we just go to 12 and then we just start counting again, right? We covered that. Now, this joke has not hit in several years. We're going to try it again. Do you really have to laugh if you think I make a joke? No. Who do I make jokes for?
Yourself.
Me. Good. I'm glad we've been through this. Okay, so check it out. This is not really a joke. What's an autobiography?
Something about yourself.
So if I were to write a book about me, it'd be an autobiography. If I were to write a book about Beatrice, it would be a biography. Okay, so I don't have any intent to write an autobiography, but if I did, pretty big part of my life is teaching math, right? So this, coincidentally, is if I ever do write an autobiography, here's the title, but it's also exactly what we're going to talk about. The power, or the powers rather, of I. Which I think is such a cool title for an autobiography by a math teacher. And we're also talking about the imaginary unit I, so it's kind of a double meaning here. Love it. Okay, as we look at this, we're going to be doing a little bit of scratch work today. If you want a piece of scratch paper so that your notes don't show it, I'm fine with it. But we're going to immediately jump into some scratch work just to connect some ideas. You guys okay with scratch work in your notes, or do you want like physical scratch paper? Okay. Because it's not going to fit nicely because we have to do a bunch of small calculations to get to the bigger idea. All right, so if it is in the star area, I have a bunch of random things on this. I don't know why. But if it's in here, it's scratch. Okay, we're going to leave this space for all the big conclusion. Now, to start off, we're going to start off with what seems silly. What's 2 to the 1? 2. Now, if I wanted to get to 2 to the power of 2, is there anything that I could do to just move from here to here? I could times 2, right? Or in this one specific situation, do you agree that instead of multiplying by 2, it's going to wind up being the same? Could I just do this and square it? Okay. And that feels odd to do maybe, but we agree that 2 squared is just this, either squared or times 2, and it's a 4. Now, with this on the board, if you don't have it locked in, if I wanted the cube of 2, 2 cubed, you might automatically default back to going, oh, it's 2 times 2 times 2, and you redo the whole problem. Or, if this is written on the board, if I want to get to 2 cubed, I just multiply by what again? 2. If I already have 2 squared, I could just multiply by 2 again to get to 8. And then all of a sudden we can see I don't have to recalculate everything each time. I just multiply by 2 again, right? Which means without having to do any thought, if I have this is 2 to the 3rd, what's 2 to the 4th going to be? So quick pause, because if you didn't answer right away, I have the sneaking suspicion that when I said what is 2 to the 4th, you forgot everything that was on the board and you started going 2 times 2 is 4 times 2 is 8. Don't. Just looking at the board,
16.
I can just multiply this by 2 to get to 16, right? And now the next one, if I wanted it,
32.
it's 32. And I could keep track over here while I'm doing this, but if I'm at 2 to the 5th, it's 32, which it is. If I right now give you 3 seconds to answer the following question, you don't have time to think it all out. If 2 to the 5th is 32, what's 2 to the 6th?
64.
How did you do that so fast?
Because 32 times 2.
You just did 2 to the 5th times 2 again. Okay, that idea. Do you guys, everybody comfortable with what's happening here? We just use the next one each time we multiply. Okay, this one, we're going to do the exact same process, but I'm going to switch to some different numbers. Now, this works for any number, right? I can do it with 3. I can do it with 5. Turns out, maybe I can do it with I as well. Now, this very first one is going to be strange, but I will make sure we work it out. We say that I to the first power, and very similar approach here. Do you guys agree it's just I? Okay. Now, for this one, we're going to go and build this up. And I'm going to make stars next to the ones that I care the most about, like the end little statement, and then we'll refine them over here. Okay. If I wanted to get to I squared, what do I have to multiply this by? I. Now, Do you guys agree that, and this is where the one's going to feel silly, I could say I squared is just I times I. Or it feels odd to write, but we could say I squared is just I squared. Like they're both true, but this one feels like almost like Y, right? So let's take a quick break and we're going to go one step further from our previous step to see if we can make sense of this. What is I exactly?
-1.
It's not just -1.
The
Square root.
It's the square root of -1. So if I said this is I, whether we're thinking here or here, those are both true, right? These are both I to the first power. Okay. If I multiplied this one by I just get I squared. Everybody cool with that? And a step ago, what did we say that I was equal to?
I times I.
So you're right. You're like completely. You are 100% correct. But up above, we went one step further. Do you guys agree that if I wanted to rewrite this, that if I'm just using the rule, not that, it's the square root of -1, and I do what to it? Squared. Is this still I squared right now? Okay, big question. What happens if I square a square root? They cancel. Now, this is one of the few times that I'm okay with that language. I prefer the word undo, but a square and a square root are opposites, just like addition and subtraction. Essentially, this happens then. Is that what you mean by cancel?
Yeah.
The radical, the square root symbol, and the square, they just undo each other, right? What am I left with?
-1.
So I'm going to make this statement, and I'm just going to write it here so it's over a little bit. We know that I is equal to I, and we just decided that I squared was equal to -1. Now, it's weird because we have to kind of shift how we're thinking about it, but they're all true. I'm just selecting the one that's going to fit really well for what's happening. Everybody okay with that?
Yeah.
If I now at I squared, how do I get to I cubed?
Times by 2.
So not by 2.
I times.
If we just multiply by I again, would I get to I cubed?
Yeah.
So then this is, I see Declan, and if I'm misreading, let me know. This right here, just to be really clear, this is I squared. Right? That's what we have here. And if I wanted to go from I squared to I cubed, just like we did with 2 squared to 2 cubed, I could just multiply again by I. Everybody okay with that? Deck, does that sit okay?
Yeah.
Okay. If I had said right here that I squared was -1, and I multiplied it by I again, what would it give me? What's -1 times I? So I'm not trying to trick you. I'm going to give you a different one. What's -1 times x? And we would just write -x, right? So what's -1 times I? And could we just write -I? Have I lost anybody here?
Yeah.
Okay.
I just don't get it.
So it's weird because we have to change form. Are we cool with step 1? I is this or this. If we square it, I just take this and I square it and I get this.
It will be the same thing, right?
What do you mean?
If it's squared or not squared, it will be the same as
Definitely not. Because I is root -1 and I squared is -1. So now, just like we did before, and maybe I shouldn't have erased the 2's, if I was at 2 squared equals 4, and I wanted to get to 2 cubed, we just take this and we multiply it by what? Times 2. If I'm at I squared right here, and I multiply it by I, do you agree that -1 times I is just -I?
Yeah.
And I promise there's a reason. We'll connect it.
Just like 1x.
Yes, just like the x, I'm just taking -1, and I'm choosing this, right? Because I could have used any of the other variants. I could have used I squared times I, just wrote it as I cubed. But I'm just playing, kind of cheating with the notation a little bit. There's no real cheating that's happening. Everything is allowed and true. It feels weird. Let's go one more. If I wanted I to the 4th, what do I multiply this by? So careful. This is already I cubed. Could I just multiply by I? And by I. And let's just see what happens here. If I multiplied this by I this last time, right now, do you agree that it's just -I, because that's what we said I cubed was, times I? What happens here? And again, I doesn't matter. Just treat it like a variable for now. We'll deal with the other parts. What's I times I? I squared. So it's -I squared. Everybody cool with that step? So check it out. We're going to do one more little change to this. And notice I haven't put a star on it yet. This is -I squared if we just follow the exponents. just like negative x times x is just negative x squared. Okay. Anywhere did we say what I squared was equal to? Anywhere in this jumbled mess?
Negative one.
Negative.
It's negative 1, isn't it? Like we already have this written and we
So
worked.
it's always negative one?
So not quite. Do you agree that I to the fourth, and I'll make sure we don't lose it, could be written as negative I squared? They're the same, and we see that works. This is where we go if we replace the I squared with negative 1. Does this have anything that we could do to clean it up? What's negative? Negative 1. Positive 1. Go ahead. I'll let you formulate.
Why did we write I to the fourth like 5 times?
I just wanted to make sure that it was very clear that all this is the same steps, like the same process. I didn't move to a new number like I did here. We cleaned up I to the fourth. If you don't like it, we could immediately jump here, but I think it's going to be less obvious to how that, sorry, that was not the jump. I think if I just do it to here, if I say, like if we leave all of them off, I don't think it's clear exactly how we get here, if I don't show that work. Okay, now, we're only going to do one more, or 2 more, or 3 more. I don't know, we'll see. If I multiply by I again, I'd be at I to the fifth. Do you guys agree with that? So check this out. I'm going to clean these up a little bit, and I'm going to do some more work in the stars, but I'm going to get rid of a bunch of this stuff. I'm just going to give us a single summary of where we're at so far. Okay, and it feels odd, but I promise there's a reason that we're going through this powers of I stuff. If you understand exponents in regular numbers, this is the same. It just feels weird because it's new. Okay, we decided that I to the first power, there's 2 ways we can write it, and it feels odd that I'm making this choice, but it's just I, right? Okay, what was I squared if you look? Negative 1. And if I multiply this by I again, I'd get negative I. And then if I multiplied it by I again, we just did all the work, but it's negative I squared, which is negative 1, which is 1. If I wanted, and I do just for a brief minute, what's I to the fifth then? How would you go from this to I to the fifth? You just multiply by I again. Do we get I?
There's a pattern.
Which means if I go to I to the sixth, I'm going to get I squared. But we already know what I squared is.
Negative one.
Negative 1, which means I to the seventh is just 1 more,
Negative I.
and I to the eighth.
1. So it's a pattern.
There is a pattern. Now, the clock discussion that we had the other day has a very similar pattern, except this only has 4 steps. That clock up on the wall has how many?
12.
12. We're doing the exact same thing, but with steps of 4 instead. Now, when we look at this, the powers of I, the way that we summarize this is I'm going to draw one small circle that we're going to reference over and over and over throughout this chapter, throughout this section. The good news, if you don't like the imaginary stuff, that's okay. This is the one little spot we see it. 99% of the time, we work in only real numbers. We don't worry about the I stuff, but we need to see it so that when we do eventually deal with it, we have at least a little foundation to step up on. Okay, the powers of I want you to write this exactly like I do. Exactly the same. Okay, for this, first little note. When solving or when working with problems like this, we never have an answer with I if or when with I with, that sounds weird, but that's what it's going to be. We never have an answer with I with a power bigger than 1. I'm going to use greater than because that's a real word. Now, we will get like practice with this, but what that means and what this is essentially saying is if we do something that winds up giving me an I squared, we don't stop. We change I squared to something else. And you may know what that something else is. We'll deal with it when it naturally shows up. We're never going to have anything other than a single I to the first power maximum in the end. Now, we and I specifically think about this as a circle because you've all spent your whole lives practically knowing how to read a clock, and you're used to the circle thought. So check it out. We're going to write it I to the 1. And this is really just I, and we're going to start here. Okay, I would have it, notice it's a little bit over, very specifically. I to the first power is 1. What is I squared? Negative 1. So there's not very many times that I do this, and I kind of hate it when it was done to me, but there's value in it sometimes. I want everybody to answer that question. What is I squared? -1. Lucy, I'm going to pick on you just because I didn't hear it. If you said it, I'm sorry. What's I squared? Boom. Dave? Boom. All right. Check it out. We're going to keep kicking. And it's like we're doing a circle, almost like a clock does. What is I cubed?
Negative I.
Negative I. Because I just take this and I multiply by I again. What's I to the 4th?
1.
I to the 4th is equal to 1. And then if I wanted to give I to the 5th, if we look over at that stuff, and Deck, you notice this right away, I to the 5th is the exact same as this. I don't have to keep going. It's just like I would say 13 o'clock. Nope, I would get to 12 and I'd start back at 1, right? We just do a full circle and restart. This is all you need to be able to do like everything that we're going to do with complex numbers. This power of I circle, this circle of I's, if you will, is everything that we're going to need for all of today, all of tomorrow. Okay. Now, where this turns out that we're going to use this is in a lot of different contexts. On the homework, if we have homework tonight, you'll see that immediately we use this in electricity stuff. Like 100%, this is responsible and helpful to developing any single electricity that you've ever used in your entire life. Okay. As we deal with this, we are going to start working with these complex numbers a little bit. Only one section for which this happens, and it's right now. So, when you learned numbers first, obviously you learned to count. That's the first step in being able to do a little bit of math. When you guys learned to count, I assume you started at what number? 1. Somebody said 0. Who was it? Did you really start counting at 0? Like right now, count to 5 for me. You did not start at 0. Okay. I don't think you've started at 0 ever, for that matter. With maybe some weird little things in Algebra 1. I don't need the book. Okay. As we're looking at this, so let's pretend it's just a regular number, right? You guys learned the regular numbers 15 years ago, 14. I don't know when, I guess kids learn to count, like 2 to 3 is when kids learn to count. I bet you knew to count at least to 10 before kindergarten.
Really?
I'm sure of it.
All I know is kindergarten, they asked how high we could count by the end of the year.
Interesting.
They'd pull us aside and have us count to them.
Yeah.
Was that good or bad?
It was good. They'd like pull you into the other room and then say.
That's not bad. My, I have a similar memory, but it's not with counting. My kindergarten teachers would pull us all aside and make us tie a pair of shoes. And I could tie, because yeah, tying shoes is a pretty important skill. I could do it on my own shoes, but if I had somebody else's shoe in front of me, it felt different, and I remember struggling and being embarrassed about struggling. I have a lot of traumatic memories from school that aren't really traumatic, like they're just the things that stick out. Anyway, check it out. We learned to count first, and then you start to learn to do some other stuff with numbers. What do you learn to do with numbers? You learn to add, you learn to subtract, you practice that for a couple of years, you get really good at it, and then you learn to multiply, then you get really good at that, and you learn to divide. Check it out. What do you think we're going to learn to do today? That. So check it out. For this, the powers of I, that's its own section. It's just really tiny. We're going to use this. We are going to be looking today at operations. So that's my, or you could call it arithmetic, but it's just operations. And I'm going to write this, but I want you guys to remind me, what does this C stand for? The complex numbers. If you need to reiterate this, I don't mind if you don't use just the shorthand. I would encourage you, if you want to write the complex numbers and really get this C locked in, here it is, complex numbers. If you're watching this and you're thinking, man, mine looks different, I don't think this is a crazy one, but I just draw a C, and then I just do a bar. This is not a me thing, this is a real thing. Cool. All right, operations and complex numbers. Here we go. Do you guys still have that visible on your page?
Yes.
Okay. So if you don't, we'll keep scrolling up, or I'll write it here somewhere. All right. So what's the first easiest operation? Add. And subtract, I would argue. But let's look at addition, and we're going to shove them together. Addition, and I'm going to shorthand ADD' for addition, and subtraction, which I'm going to use this contraction for subtraction. Okay, addition and subtraction. Now, here's the deal. I'm going to leave a little tiny space to explain this, but we're going to pretend for just a second that this is the first time that anybody's ever seen the complex numbers. And I know that it is pretty close to the first time that you guys have, but let's pretend nobody's ever done anything about them, and you get to write the rules. For this first one, we're going to add a little comment. It's like 3 words, 5 words, one little tiny line, but we're going to jump right to an example, and I want you to add the following for me. Now, you might be right. I have a feeling, I think everybody will be right if you try something. I just want you to go with your gut. If we're wrong, it's okay. We'll make sense of why you're wrong, but I want you to try one first. I'm going to give us 2 complex numbers. And let's say we have 6 plus 7i. And I want you to add to this complex number 3 minus 2i. Now, I've only included the parentheses so we can really clearly tell one complex number right here, even though there's 2 parts of it. It's a single complex number. Purely with your gut. I've not shown you how to do this, nor told you how to do this, but if you got to write the rules to how we combine these, how would you want it to work? And I want to talk with your neighbors, do it independently. I want to see what you come up with. What do you think this equals?
Oh.
You could have written these rules with one little exception. Just kidding. You could write these rules. There's no exception. That's perfect. So right now, I've never shown you how to do this, right? So do it. How would you do it? If you got, like, you don't know any of the rules, what do you think you want? Like, what should you add? That's 6 plus 7i. So that's my first complex number. Then I have 3 minus 2i. Okay, if you are struggling, I'm going to give you a very similar problem that looks much nicer, but it's really the same thing. What if I asked you to add these together? Could you do that?
Yeah,
Yeah.
that's all I did.
And if you tried something, that's probably what you did. If I look at this, remember, every complex number has 2 parts, right? We have the very real part, and we have the imaginary part. Like terms are still a thing that exist. With the x's on the board, that's what we have to do. What's the real part of this? 6, and what's the real part of this?
Oh.
Those are the same, right? They're like terms. Let's just add them together. What's 6 plus 3? 9. So check it out. I'll switch. And does that feel natural as a choice for what to do? How many of you had that before I started talking about it? No, you didn't. Not you. You did. You did. Yes. Okay. That sounded or felt kind of rude. David, you did have it, and it was perfect. Okay. Do we all agree that it's 9 plus 5i?
Yeah.
Now, if you need it, I don't know that we do, but we could split it up smaller. I just spit all over my book. Whoops. I could add the real parts like this, 6 plus 3, plus, and then you could do the imaginary parts. And I'm going to do this probably different than you would, but is that the same thing?
Yeah.
Or you might even do 7i minus 2i, like this. But this is probably what you did, whether you thought about it or not. We all got this answer. Okay, if I said, what's the rule for addition or subtraction? You guys all can do it, seemingly. How would you say what we just did?
Add like terms.
Good, like terms. And I'm going to change, like, it is correct, add like terms. I'm just going to say real plus real, and then plus imaginary plus imaginary. Now, like terms is a much more concise way to do it, and it's correct. This is a wordier way to say it, but is that the same thing? Is this still saying add like terms, just with different words? Yeah, add the real parts because they're both real. Add the imaginary parts because they're both imaginary. Okay, like terms is all that we're after. Which means, if I give you another one, and I'm full disclosure, I'm trying to throw you a curveball here. I'm going to give you one more. I want you to do 2 plus 3i minus 4 minus I. Try it out. If you make a mistake, I'm already anticipating where I think it's going to happen, but I'm going to give you guys like 15 seconds. Are you ready?
Probably just wrote it backwards, but I don't think the order matters.
So, truly it doesn't. It's standard to do it the other way around, to have the I at the end, but I disagree. I think one little part is wrong. And you happen to make the same mistake.
Interesting word. Alright.
I agree. You made the same mistake. Bad. Did the parentheses have any impact on part A?
No.
No, like I put them there so we could see the numbers very clearly, right? On B, do the parentheses have an impact? When I see a negative and a parenthesis, what did a lot of you guys forget to do when you encounter a negative and a parenthesis? We have to distribute it. It's just like every other binomial. These parentheses were not optional. It makes a difference. When we do this, it's an easy mistake to make, but it's equally easy to fix. This first number, do these parentheses matter?
No.
No, like, I mean, if you want to distribute a 1, you can, and that's fine. You get a 2 plus 3i. But when I distribute this one, what changes? Minus 4 plus I.
That's what I had.
Did you really? Did you have 4i?
I have 4i minus 2.
I'm sorry. I saw 2 minus 4i is what I saw.
Oh.
That's my bad. Sorry about that. My bad. You're good. Sorry. Real part should always come first. A plus bi is how these numbers look. What's 2 minus 4? Negative 2. What's 3i plus I? So I heard 2 answers.
Plus 4. I.
Plus 4i. Okay. Did anybody else have it right and I told you you were wrong? Okay. My bad.
No. Oh, I see.
2 minus 4. And then 3 plus 1. Okay. Does this seem doable?
Yeah.
Just for the record, this is a mistake that I was indeed expecting. People forget to distribute it all the time. It's an easy mistake to make.
Wait. Oh, I see it now.
Care to add insight for us, or you're good?
I didn't know how you got -4, but it was from distributing.
Yep. Awesome. Okay. So, decision time. Do we do another one just like this, or do you want to bump it up to 3rd grade stuff?
3rd grade.
All right.
Bump it up
Yeah.
to 3rd grade.
Yep. Cool. So this was like kindergarten, right? We're adding. Now it's not really kindergarten, right? Because it's complex numbers, and you don't see complex numbers until you're sophomores or juniors, typically. Cool. What's the next operation? We just covered addition and subtraction. Multiplication. Let's deal with that one first. Okay. Complex numbers, when we write them out, they have 2 parts. What's the normal format of a complex number? A something. Complex numbers, what do they look like? A plus bi. Real quickly, how many parts do they have then? 2. Do you agree it kind of looks like a binomial? Okay. So with that in mind, that's all I'm going to say. We're going to do the same thing. I'm going to leave a blank note, and we're going to just pretend that you get to write the rules with the understanding that I just gave a huge hint. I want you to multiply the following. I want you to take 2 plus I times 3 minus 5i. Okay. I'm going to let you start it. You know what? I'll let you finish it. If it's wrong, it's wrong. I haven't shown you how to do this. Show me what you think happens. So you're close. So no, you're not wrong. You just don't have all your answers. Are you done? Okay, keep going. Okay, so let me start your pencil. I'm gonna give you a different one to do this. Distribute that one for me, and just show me how you do this one. So now, like, it might be stressful, but I'm gonna sit here and watch. I'll look away from you. What is the F word in my mind right now? So I heard 3 really good F words there. Foil.
Oh, it was wrong.
No, what?
Factoring is when you break it down. Foiling is when you distribute.
Reverse factoring.
Yes, reverse factoring. So, careful. You're running.
That's why I can't do it.
Oh yeah, do the same thing. Ooh. So kind of. These ones you did just to match these up. I'm gonna draw one thing. You remember doing 2 times this and 2 times this. Inside and last. Yes, those lines are fine. So just showing me real and real, imaginary and imaginary. All right. Can we foil this and just treat it like it's a regular binomial. Okay, hook it up, because I don't remember how to FOIL, which is kind of embarrassing, but here we go. F for, see, I don't really care what it's for if you guys don't know. First, what's the first thing that I do?
2 times 3.
What's 2 times 3? 6. What's the next thing I do?
2 times -5.
Ooh, 2 times -5i.
I did it.
Negative 10i.
Yes. I got that.
I times 3.
3i.
3i.
And the very last one,
-5i.
squared. Okay, now we're going to take little steps here. We're not completely done, but we're close. Because earlier on the powers of I made a comment. We're never going to leave an I with a power greater than 1 in our answer. Do I have an I in my answer? Does it have a power greater than 1? So we're not done. I'm going to do 2 things in this step right now. I'm going to combine, I won't take a square root, and the reason I won't take a square root, love that thought, is because if I take a square root and I have an equation, I have to do it to the left and the right. What's on the right? Sorry, what's on the left? Nothing. There's nothing over here. There's nothing for me to take the square root of. This is not incorrect, but maybe the arrows would be better to show like this leads to this, leads to this. I use equals because they're all equivalent. Okay, so let's combine like terms first. This is 6, and then what's negative 10i plus 3i? Negative 7i. So that's my like terms, and I'm going to do one more step here. Minus 5, but I don't like I squared. Gosh, if only we knew what I squared was.
So it's just negative. So 5. It's just 5.
Good. So, Kian, just in case I misheard, when I said what's I squared, did you say square root of -1 or just -1? So what's I squared? There it is. Okay, so one last little line, maybe 2. This is still 6. I changed colors on accident. 6 minus 7i, and then this is minus a -5, plus 5, and we will go one step and we're done. Any other like terms?
5.
11 minus
7.
7i, and we are completely done. Okay. Before we started, I could tell, like right off the bat, nice job, everybody who seemingly started to FOIL, because that's the natural thought with this. Are they really that much different than stuff that we've done? With the exception of now we can take a square root of a negative. Your calculator has never once said this doesn't exist. All your calculator says is there's a domain error because your calculator only understands the real numbers. It doesn't understand the complex part. You're smarter than your calculator at this point in time. Okay, should we do another one? Good. All right, on B, I want you guys to do the following. I'm going to give you 2 more. B and C, okay? Check with me about B first. 3 plus I, and I'm going to multiply this by 3 minus I. And then once you get B done, there will be a C up here as well. If you didn't get them correct, that's okay. I bet you're most of the way there. Let's check this out. On Bravo, I'm going to FOIL. What's the first part of my FOILing, my distribution?
3 times 3.
So I will actually draw the lines. And what's 3 times 3? So I'm going to say equals 9. And then what's 3 times -i?
Negative I squared.
So careful. 3 times -i. Is it negative 3i?
Yeah.
What's I times 3? Positive this time. And then this last one. So we'll get there, because here's the issue. Some of you guys are naturally going to try to skip steps. I have no issue with it, but let's wait until we do these few examples before we start trying to skip stuff. Okay. Anything convenient happen here? Negative 3i plus 3i, they're gone. It's just 0, right? They fall out. So all I'm left with is 9 minus I squared. And I'm going to take little steps. Gosh dang it, that's a power bigger than 1. If only I knew what I squared was. What's 9 minus -1? Boom. Did you do this last one too?
Yeah.
I'll come look in a second.
I don't know if it's correct, though.
We'll see. Okay. If you got this one wrong, where did the mistake happen? Just out of
I
curiosity.
stopped at 9 minus I squared. You need to
Okay, so the good news is you're not wrong, you're just not done.
Yeah.
I already simplified negative I.
I,
So I turned it into
I think I
negative
found
one.
a shortcut. Though.
I'd be careful. Like, show all the steps for now. You will be able to skip stuff in about 3 minutes. This one, talk it through. Do you guys want to try it?
Talk it through.
Okay.
It's 29, right?
Yep. If you have 29, Jade, go ahead and start this one. And then when you get an answer, compare with deck. All right. This one, FOIL is 2 times 2, right? You can move over there so you don't have to shout. The next one gives me a what? 4, and then,
Negative 10i.
okay. And the insides
10i.
and the outside.
Negative 25i.
One more word.
Squared.
Love it. First step on this one. 4 minus 10i plus 10i, and then minus 25i squared. Do you notice anything convenient happen?
Cancel.
Gosh, it's like the same thing that just happened, right? That's pretty cool. Okay, so day gone. And then let's take little steps again. This is 4 minus 25i squared, but that dang 25i squared. What's I squared?
Negative 1.
Which means this is really just 4 plus 25? And it's 29.
Oh. So the negative 1 cancels out I squared.
So, no.
Well, not cancels it out, but it's the same thing, so.
Yes, and I'm going to be really specific here if you want to add this. I'm going to make a little note. Substitute I squared equals negative 1. Anytime that you encounter I squared, this happens every time. Now, we didn't do one here, but we could do one where we get an I cubed, and then I would just look back at that powers of I. If I had an I cubed in my answer, I just replace it with a minus I. Okay. All right, so Deck and Jade, I want you just to check, we'll compare the answer, okay? Let's do part D together for everybody, and I assure you, it's not just to like practice, practice, practice. There's a shortcut here.
I found it, I think.
Okay, help me FOIL this one out. And it's uglier, but that's okay.
A squared
A times A is A squared. Love it.
plus
A times BI.
So I think it'll be minus. And I'm going to change the order. This is ABI. ABI. When I do this one, you're going to be tempted to call it BIA. You could, but there's a better way to write it. It's still A, B, and I, right? So I'm going to write this one. I'm going to rearrange it to make this look very obvious what happens. Plus ABI. And then this very last term is the ugliest part. Before we do the next part, did I lose anybody in this step? Okay. I need help with this one. How do you guys write this?
BI squared.
Okay, so I'm going to write it the way you said it, and it's purely just an issue. Is this what you said?
Yeah.
I don't think it is.
B squared.
If you want this, it's this, because it's BI times BI.
That's what I had.
Okay,
My friends.
so then no.
That's not it?
No, like I'm just messing, because you said, is this correct? Like, yes, you're good. Sorry, I was trying to make a joke. You are correct if you have parentheses.
Okay.
Okay. All right. Anything convenient happen on this one?
0.
They're gone again, right? It happened again, which is super convenient. Okay, which means I have left A squared minus, and this is going to be the ugliest part. Do you guys agree this is just BI times BI?
Yeah.
Do you agree that it's weird, but could I say BI is just B squared, I squared?
Yeah, that's right.
So check it. And like this, if you're going to get goofed up, it's going to happen here. BI squared literally means BI times BI,
Yeah.
which is literally just B times I times B times I, which if I rearrange this is B times B times I, which is exactly B squared, I squared.
Yeah.
Okay, you do not have to do this every time. That's like every step along the way. Okay, does anything happen here? Or, yeah, I don't like I squareds, and that's okay. I'm going to substitute negative 1. What happens? A squared
Plus
One.
B squared.
a squared minus a negative b squared becomes a squared plus b squared. Do you guys...
Oh, because you're
Yep.
multiplying the negative b squared and
Yep, and I'll even do it here. A squared minus a negative b squared is what we get when we do this multiplication. And now we'll go that last step, a squared plus b squared. Everybody okay with that? Okay, I want you to burn this into your brain. And it will happen naturally because check this out. The last two problems that we did, they had this same format where it's a plus and a minus. Check this out. In this situation, this is a complex number, a plus bi, right? And this is another one that's just the same number, but it's a minus bi. Check it out. Can you tell me what a is here, Jade?
Wait,
On b.
Oh, B.
That's super misleading. What is the value of a on this one?
3.
3. What's the value of b, the number in front of I? 1. Do you guys know what 3 squared is?
9.
So that's cubed.
Oh,
3 squared is 9. You were correct over here. What's 1 squared?
1.
And if you did 3 squared plus 1 squared, what would you get?
9.
Ten.
Wait,
Wait,
Can you
3 squared plus 1 squared is 10.
Yeah.
Huh. Okay, check it out. Do we agree a is 2 right here?
Yes.
And b is 5?
Yes.
What's 2 squared?
4.
4. What's 5 squared?
25.
If you add those up, it's 29. We have the rule, the shortcut, right here. If we have this number, a plus bi and a minus bi, and we multiply them together, you just take the square of the first number, a, plus the square of the second number, b, every single time. Now, this is so important that you've actually seen the word before, not with the complex numbers. Do you recall, rather, the word conjugate?
Yes.
Okay, you do not have to do this where you've seen a conjugate before. You guys dealt a lot with radicals last year, right? You did a lot with square roots in geometry. Okay, inevitably, you did something like this.
Oh, yeah.
Oh.
Yeah.
What can't we keep in the denominator? The square root. So how did you fix it?
Cut the five off.
Cube.
You said,
Oh no, that's for powers.
Negative I.
so no i's involved yet, because this is from geometry. You would multiply by a clever choice. What number doesn't change stuff? 1 is the only option, right? But we can write 1 however we want. In geometry or algebra 1, you did it like this. Root 5 over root 5. What's this number?
1.
1. So if we did this, and you don't have to write this one down, if we multiply straight through, do you agree we get 2 root 5?
So then 2.
Over
5.
root 5 times root 5 would be the square root of what number? 25. And you go one step further and you would say 2 root 5 over, what's this number?
1.
5.
5. This is a very geometry problem. Where you,
Change 25 to 5.
because what is the square root of 25?
5.
Yep. Okay. This is not our focus right this second, but I guarantee if you didn't burn all of your geometry stuff at the end of last year, you still have it?
Huh?
You still have your geometry stuff?
I didn't burn it, I threw it away.
Okay, so potato. It's obviously potato, right? Okay, whatever. Cool. This, I guarantee you've done it before. I said that one day and somebody looked at me like that was crazy. I said, what? And I just told them I would only ever read that saying. I still don't know if you guys caught the joke, but I find it hilarious. Yeah, or you say potato.
Potato.
Cool. Yep, that's also a meme that's going around about the potato. I don't know. Not my thing. I don't know. There were boys chuckling about this. Okay, so we're going to define this. You guys, whether you remember doing that in geometry or not a huge deal. I just noted this. We're going to do this little part. It's a subsection. We did addition and subtraction. We did multiplication. There's one more. Division. Now, we're not jumping right to division yet. We're going to sneak something in first. We're going to define for ourselves the complex conjugate. Now, I will never write this out like this again. Do we have a shorthand for complex? The Blackboard C. So check it out. It's stupid, but it saves time because we're going to write this so many times. This is how I shorthand this. I just use that Blackboard C to very clearly say I'm talking complex, and it's the conjugate. Okay, now what we just did with the radical stuff, whether you remember doing it or how to do it and all that good stuff, we'll review it in here naturally. But you've used a conjugate. It just happened to not be a complex one. As we go through here then, super easy to define. Given a complex number, and we're just going to write it immediately, a plus bi. The conjugate, or the complex conjugate rather, and I'm going to sneak this in, is simply, I'm going to change color so it stands out. Nothing changes except this sign right here. A, instead of plus, what do you think I should write? What's the opposite of adding? Boom. A minus bi. That's it. If I give you any complex number, its conjugate is found, and the book defines this with wordier version. They say it's a complex number with the same a and b value, or the same a value and the opposite b value. That's ugly. If I give you a plus bi, the conjugate is just a minus bi. Alternatively, if I started the other side, I want you guys, don't have to write it. This is just think over here. What's the conjugate of this number? Here's a complex number. What's its conjugate? 2 minus 3i. That's it. Should we do another just basic practice, or are you guys ready to make the jump to division? Let's jump. Okay, for division, it is different than all the other operations. Now, not in a bad way necessarily. You guys like division or not really? Like long dividing and stuff?
Not really.
Never.
When it gives you nice numbers.
Never
I
learned
like
how to
it.
really do it.
Ooh, really?
I don't like
To do it like a number over a number and divide.
So like if I said what's 173 divided by 21?
it.
You never learned to do that?
I can't do that.
Okay, we will. We'll have to. Not this year. Okay, so check it out. Here's the good news. Division. It does not make as much sense in the complex numbers. If I say what's 5 divided by 2, I'm wondering how many times does 2 fit into a group of 5? And it's 2.5. Like whether you can do that or not, I'm not super worried about it. For division here, we essentially are doing the same thing, but we don't have the capability to think in this extra dimension that we call the imaginary numbers right now. Okay, with that in mind, when we have division problems, all that we're really doing, and our goal is we are simplifying an expression, simplify, so that the denominator, which part of a fraction is that? Good. The denominator doesn't have imaginary parts. And I'm going to say have any imaginary parts. That is the only goal here for us.
So the eyes?
Yep, we don't want any I in the denominator when we're done. That's it. Now, something really handy happened when we were doing multiplications a moment ago with our conjugate. If I give you a complex number times its conjugate, and I'm going to scroll back over to here so we can see them. Oops. So check it out. B and C are these examples. Here's a complex number and its conjugate, right? When I multiplied these, they both had an I in them. But at the end, did it anymore? No. We have a way to break the I's out of an expression. Now, we're going to use this idea of the conjugate and the understanding that all we're really trying to do is get rid of that imaginary I value in the denominator and put these together. So let's knock one out. Here we go. Example, I just want to divide each of the following. Now, we could write it with the division symbol, the bar with the 2 dots, or we could write it as a fraction. We're going to default to just fraction every time. So here we go. Let's do our first division. I want to divide 3 divided by 2 plus I. Okay, we can't and won't think of this as regular division. I'm not saying how many times does 2 plus I fit into 3. It doesn't make sense. We can't reason that. What we can do, however, is simplify this such that the denominator doesn't have any i's in it. So here we are, And I've asked this question before. I guarantee I'll ask it again. I need to change this somehow. Do I have an equation written here? Is there an equal sign anywhere?
No.
So there's nothing that I can do to both sides, right? So it's not like I can add 5 to each side or whatever the case might be. There's no reason you would add 5 here. What number can I multiply by that won't change it?
1.
1. There's a bunch of ways that we can write 1, right? So check this out. For this very first expression, we saw that if I take a complex number, there's something that I can multiply by it such that the i's are no longer there. What was it? Ooh, louder? The conjugate. If we can multiply by a choice of 1 using the conjugate of this number, we're golden. What is the conjugate of 2 plus I?
2 minus I.
So check this out. If I multiply by 2 minus I right here, am I allowed to just do this?
No.
Not quite. Now, you might realize I'm going to add another piece here. What's the number again that I'm allowed to multiply by? Any choice of 1. If I want whatever is green here to be 1, if 2 minus I is in the denominator, what must be in the numerator?
2 minus I.
2 minus I. Now, the annotation, the language that I use, this is a clever choice of 1, and you'll hear me say that like a billion times, probably not literally, but a clever choice of 1 found by what? How do we decide on that number? The something of the denominator. This and this, they're related. The conjugate, the complex conjugate specifically. Okay. I didn't have to spend a ton of time thinking about what the conjugate is because I just use the conjugate of the denominator. At this point, I've multiplied by 1. It looks different and it's going to look different, but we're doing this because I know for a fact that when I multiply these, I don't have an I in my answer anymore. So here's what I want us to do. We're going to do this first one together, and we're going to try to embrace the shortcut, because if we don't do that together, people are going to forget about it. The numerator is not crazy. What's 3 times this?
6 minus 3I.
Okay, everybody square there. Now, do we have a shortcut for a number times its conjugate? Did we work out a shortcut?
2.
What's the number in front of the I that I didn't write? I will write it this one time. 1. Which means, do you guys agree that this is A and B? Well, what's our shortcut? Tell us what we need to do. Let me rephrase that. What did example D on multiplication tell us happens if we take a complex number, A plus BI, times A minus BI?
1 squared, so then it's
A squared plus B squared, right? So A squared plus B squared is what I'm after. What's A in this case? 2 squared is 4 plus 1 squared is 1. And I'm going to annotate this one again. I'm changing colors, trying to keep stuff straight. If you guys use all these little details here, you are more than welcome every single day to grab colored pencils, all that. Like, your notes will look nice. Looking at this, I just used this shortcut, A minus BI times A plus BI equals A squared plus B squared. Every time this happens. There's a reason that the conjugate's so convenient. Now, we're going to take 2 little steps to finish this problem off, but we're about done already. This becomes 6 minus 3I divided by 5. If you stopped here, I'll accept it. I'll give you the point. I'm always going to comment on it, though. Complex numbers always have the same form. It's something plus something. At the very beginning, every complex number that we've ever written has the form something plus something I. It's normally A plus BI, but the letters don't really matter. Can I split this up? And what I mean by that is this allowed? 6/5 minus 3/5 I?
Yeah.
I can split up a numerator like this. Can I do it if it's a denominator? So we cannot. We can split up a numerator. This is the form that our answers ought to be in. Okay. Weather just can't decide. Here's the deal. Tomorrow, bring your imaginary hats. We're going to be wearing them. We're going to be doing a bunch of this stuff. I want you to do one more problem for me, and then we won't have homework tonight. We'll use tomorrow to work on this stuff. Cool. I want you to do one more division. 2 plus I divided by 6 plus 7I. Okay, here's the deal. We have 60 seconds. You may not finish this problem. I know I just said I'm not going to give you work tonight, and I'm not going to give you problems. I want you to come back tomorrow with this one done.
Like morning?
I mean, ideally by morning, but definitely by 2:10, 2:05 tomorrow. By the start of 6 hours. Cool. This one problem is your assignment. Cool. Try it out. If you're wrong, bummer, but that's okay. Try it. That's it. Even if you forget about it from now until tomorrow, right before our 6th hour. I will never know. I just want you to try it before class. Later, Raiders.